So now we've got three different sets of terms here. We've got w squared terms. I'll put a double line under those. And we have just w terms. And we have constants. Like that. Just emphasizing the three different types of terms by underlining them just to keep organized. Now again, when we open up the second bracket, we have to be careful because we've got this negative sign here, and this is like a -1 multiplying into everything inside this bracket. And so we have to take that into account. So let's open the first bracket. That's easy enough. This is 4w squared. This just opens up because there's nothing in front of the bracket here that we need to worry about at this point. So all of those terms just come out of that bracket, no problem. We can get rid of these brackets here. But now this is like that -1 that multiplies times every term. Terms are separated by positive or negative signs. So this bracket has three terms, all separated by positive and negative signs. And inside this bracket, we have three terms as well, in this case just separated by the positive signs. And we've identified them with these different markers underneath here. So -1 times 9 is going to become -9w squared. This becomes -2w, because that -1 multiplies times that term. And the -1 multiplies the +5. So when we multiply a negative times a positive, we end up with a negative. Now that we've got that done, it's a matter of collecting all these terms, the like terms. And again, we can use the same indicators that we did above. We've got two w squared terms, or second order terms. So 4 minus 9 becomes -5w squared. We have the single order terms here. We've got +6 and -2. So 6 minus 2 is still going to be +4w. And our constants last are -8 minus 5. So we're starting at -8, subtracting another 5. We end up at -13 as our final term in our answer. And we're now done. So that there is now the end of MFM1P Unit 2. This first question asks us to state the like terms in each of these two groups here. This is A. And like terms have the same, exactly the same type of letter configuration here. So when we look at this one here, this grouping of terms, okay, and these we can separate all these by commas if you want, just to really emphasize. These are all separate individual terms. We have an x term here. This is a single power x term, and this is also a single power x term. This is x, but it's x squared. So this is considered a different term because it has a power attached to it. So if we just use some little indicators underneath of these to group them together to answer this question, we can say that this term, the 3x, is the same as this term. These are like terms here. So this is an x term, even though it has a 3 coefficient in front of it. And this is also an x term. It has a -1. Okay, again, whenever we see a negative sign, we can assume that there's a 1 buried in there in math. Okay, we just don't write it. Since we've already talked about this term, the squared term, the x squared term, this is a term unto itself. Okay, so this is another type of term here. So I'm just going to use a different indicator, double bar. And there's only one of those. I don't have any other terms in here that have x squared, so that's our second type of term. When we look at y, just working from left to right here, we look at y, when I scan across the remaining terms here, there are no other y's. So this one's by itself. I'm just going to put a little squiggle underneath that one. Z, again, I look at my remaining terms over here. This is W, that's V, so this is a unique term unto itself. I'm going to go a double squiggle there. W term, again, I have no other W terms. These are all taken care of right here, so I can, let's just make a triple bar underneath this one to emphasize that. And the V, I think you're catching the idea. There's another term there. So in terms of number of terms here, the question doesn't really ask us to do this, but in terms of the number of terms, this is one type of term. I'm going to call that style 1. We have this style, that term, that term, that term, and that term. So there are actually 3 different terms. Sorry, 3. 6 different terms in this collection here. Okay, we have x squared terms. If we start with the highest order, then we have x terms, y, z, w, and v. So there are 6 different terms in that particular question. And if we look at the next question, b, okay, we have a 4x. Go a little faster on this one. 3y squared, 4z, 2y, y squared, and 4w. Okay. And when we just take a quick look across here, I have no x's, so I'm not going to waste any time on that one. There's no other x's in here. Moving to the next term, y squared. Yeah, that's a y squared. And jumping over here is a y squared. I have no other z's, no other single y powered terms, and no other w terms. Okay. So these are the only 2 like terms in this collection right here. These are all other independent terms. So if I look here, if I state how many types of terms there are in this collection right here, that's the same as that one, right? That, so I have 5 different types of terms in that question. Okay, that's it for number 1. Moving on to number 2. Number 2 asks us to simplify. Okay, number 2 is asking us to simplify these expressions that are given to us. I just need to jump over to that question it for a second, it's a little bit light. So I've got negative 3x plus 2x. Sorry, negative 3x plus 3 plus 4x plus 2. That's the first question. Okay, so A, and there's no brackets here, negative 3x plus 3 plus 4x plus 2. Okay, so remember what we just did above here where we first identify and then collect our like terms. I have single x powered terms here and a single x powered term here. These are constants, okay, and so they go together. So I have two types of terms here. I have single x powered terms, and I have two constant terms. So in terms of simplifying, I'm just going to collect these terms together. Once I've identified the term, I really don't even need to consider the variable anymore, the x. I just need to look at the coefficients and deal with those mathematically. So this is negative 3, that's plus 4. Negative 3 plus 4, it becomes positive 1. I could write the 1 here if I wanted to. Okay, I'll just write it in here. This is going to be positive 1x because negative 3 plus 4 gives me positive 1x. Again, don't need to worry about writing the positive here as a leading coefficient. And then I deal with two constants here, 3 and 2, so that's plus 5. Okay, and this is done. Okay, and the 1, like I said, that's optional. You could leave the 1 out, x plus 5. This could, and very more normally, be written in this fashion here as well. Okay, that's not wrong, but it's just not necessary either. We would just go x plus 5, and that's done. Okay. Should hopefully have enough room here. Squeeze in B. And I just need to reposition B here so I can see it. And it looks like they've just got a bit of a typo on the exercise here. There's a trailing bracket there, but there's no front end bracket. Unfortunately, we could kind of interpret that different ways, but we're just going to ignore that bracket at the end, and we'll just deal with this straightforward. So we've got 3 minus 5n minus 6n, and again, it's a little bit, and that's minus 2 at the end there. A little trouble seeing that on the video feed at my end. To jump back and forth a little bit. Let me see if I can maybe zoom in on that. That might help a bit. And there we go. That's a little bit better. Okay, so in this question here, just draw a little line. Let's identify the terms. Okay, always good practice to do that. We have n term and n term. Again, the sign goes with the term. Okay, so that's a negative 5n. This is negative 6n. This is positive 3 constant, and that is negative 2 a constant. So again, we have two different types of terms. Okay, two types of terms. We have n terms here, and we have constant terms, and we're just going to collect those in the process of simplifying. So the algebraic terms always come out in front. They come first. Constant terms, as you can see here, and as we've always done it, the constant terms come at the end once we're properly and completely simplified. So here we have negative 5. We're starting at negative 5, and we're subtracting another 6. So negative 5 minus another 6 leaves us with negative 11 as our integer value, and then I tack on the n. Okay, nothing changes with the letter. This is just how many n's we have and how many n's we have here. Put them together, I've got negative 11 n's. And then I look at my constants. I have positive 3 here. You can write that in if you want. Positive 3 minus 2. 3 minus 2 is just 1. So I write plus 1. And this is done. Okay. This negative sign has to be here because it's negative 11. Okay, so I have to make sure that I indicate the negative sign out in front right there. And the question is done. Part B is done. Okay. And I have to go back to the other page and just reposition that. Part C. Yeah, part C is definitely more of a challenge. Got two large brackets here, okay, with 3 terms in each. So we'll just write this out to start with. And again, I really encourage you to write out the question in your notebook completely to start with. If there's one place that I see students certainly make mistakes right off the hop in math and solving math, it's that they like to cut corners on writing out their solutions or developing their solutions completely. So just save yourself some easy disappointment. Take the extra 5 seconds to write out the question properly. Okay. Now, if there was any like terms inside the brackets, we could simplify those first. With bedmass rules, the first B in bedmass is brackets, so we would look at what's going on inside each of these brackets first, and we could deal with that. But this is a squared term, an A squared term. This is an A, single A term, and this is a constant, and we have the same collection of terms on the other side. There's no more simplification that can happen there. So what we need to do is we need to just open up these brackets so that we can collect the like terms in those two brackets here, and we can push this all together. Now we have a plus sign here, so this is really nice. You know, we don't have to worry too much about opening anything up here. These are all going to be just the way they look inside the bracket. When I multiply everything by +1, nothing's going to change. Okay, so we put an equal sign here, open up the first bracket, and again there's nothing in front of the first bracket I need to worry about, so that becomes 8a squared plus 2a minus 3, and this becomes what it is, negative 5a squared plus 4a plus 7 at the end. Okay, so we've got these all opened up now. And now let's go ahead and identify the like terms that we have in this one large expression now. So we've got the a squared terms. Again, don't forget the sign goes with the term. We have single a terms. And we have finally a couple of constants there that were at the end of each of the brackets. Okay, so we've got them all identified easily with these little lines and squiggles, and then we're going to go ahead and collect them together. And again, we're just looking now at the integer value of the coefficients. Coefficient is the number out in front in the variable term. 8 minus 5, straightforward enough. 8 minus 5 is 3a squared. Put the a squared there. I collect now my a terms. I have 6a. And with my constants, now I have -3. I'm starting at -3, and I add 7. And so that leaves me with +4. Okay. That question's done. Okay. Okay, so moving on to D now. Again, we've got two brackets here to start with, and each of them, just like in C, have three terms in each bracket. That's the first bracket. And now the second bracket, there's a minus sign between them, or a negative sign. And the author has chosen to write those last couple of terms out of standard order. And I say out of standard order because standard order, usually you go with in math, you go with the highest order power terms first. So we have the squared term here, it's written first, and you can see the squared term is written first here. Then the next term is the next highest order, which in this case is a single power. And again, we understand there's a 1 right here as the exponent, but we don't write it. So the single order term comes next, and then the constant comes last. In this bracket though, the author, I'm not sure if this is a typo or if this was on purpose just to make sure you're on your toes here, but chose to write this x squared term after the constant, which would be sort of a non-standard form of the expression. It's not wrong mathematically, it's not the way that we normally write things. We have lots of rules in English, we have lots of grammar rules in English, and even if you break a grammar rule, it's maybe not that you don't understand what the person is trying to write in the sentence, but it just seems a little bit awkward because we follow these rules. Same thing in math. Okay, so we're going to open up these two brackets here, but unlike the question above this where it was a positive sign, so it made opening up the bracket very easy, in this situation here we have a negative sign. Okay, and so we have to be careful here because this is like a -1 that is going to multiply every one of these, so the negative is going to affect the ultimate sign that comes out. Okay, because we multiply by a negative, it can have that effect. So let's open up the first bracket here. This is just going to be what it is, okay, because there's nothing out in front of that first bracket to mess anything up here. This is just the way it is right here. But the negative sign here, this is now -1 times +4, so this becomes -4x squared. Negative times positive again, that's going to become -5. And a negative times a negative, remember that little sign chart that I had on the previous page, negative times a negative becomes a positive. That just follows through from logic. A double negative is a positive. Okay. If you wanted to rearrange these two terms at this point here when you expand it, you could. I would suggest just dropping it out. We'll worry about rearranging and making everything in proper order in our next line down here. So let's again take the few seconds to identify the like terms. So the squared terms we identify, the single powered terms we identify those, and we have the constant terms as well. Finally at the end, -6 minus 4. So -6 subtract another 4, we have -10x squared when we put these two terms together. And the next set of terms we're going to look at is the x terms, the single x terms. We have +5 and +2, so that becomes +7x. 5 plus 2. And then we've got +2 minus 5, and that just leaves us with -3 as our final answer. Okay, and we're done. Okay, so moving on to E now. Again, start by writing out the question. And what we see here right away is that the two brackets, the collections of terms in the two brackets, are in reverse from standard order. It's going from the constant to a single order variable, and then to a squared or a second order variable here, and the same thing goes on here. And what we also notice is that they're using two different types of variables here. We've got an n based variable here, n squared, and m. Not that it really matters, because as we saw back in the other question, if it's a single x, the single x does not combine with an x squared term anyway. So it's not that these two variables would ever be combined, those terms. You know, this x here might as well be a different variable from the x squared in terms of being able to combine them. They are two very different types of terms, just like these are here as well. Okay, so we're going to first open up these brackets. Again, there's nothing out in front here that we need to worry about, so opening up the first bracket is very easy, and because that is a positive sign here, this is like a positive 1, and we multiply all of those terms times positive 1. It's not going to make any difference to those terms. So let's just go ahead and open this up here. So we have 3 minus 2m negative n squared, and then that's going to be plus 7 minus 6m, because positive times a negative still stays as a negative, and positive times positive here, we have n squared at the end. Okay. As always, we will identify terms. Let's stick with the squiggle for our constant terms. Okay. And I was using a single bar under the higher order terms here, so the squared, n squared in this case, and we'll go with the double bars under the single powered terms here, singular terms, just the m terms. This is interesting because what we have here is we have negative n squared and positive n squared, and negative 1 plus 1, that just canceled out. So really these two terms disappear at this stage when we combine them together, so I won't have an n squared term in my final answer. So even though I have three different terms in both of these brackets, just like I did in the previous questions, there was three terms and our final answer ended up being three terms because there was three unique types of terms. In this case here, one of my types of terms just completely cancels each other out. So now I'm going to move on to my next terms, which is the m's. So I've got negative 2 minus 6, so that's going to be negative 8m. Okay, negative 2 minus 6 gives me negative 8m. And then the constants come in at the end. 3 gives me 10. Now that is the complete final answer for E. Okay, so I would suspect by this time you should be able to handle the remaining F, G, and H questions in that problem. Again, if you flip to the back of the book, it has a lot of these worked out, and it has the solutions for those questions available at the back. I'm going to jump down to number 3 now. This is a little bit different, adding an extra step. So 3, it says to simplify, so we have to simplify, do the same thing we're doing, and I'm just going to scroll this across here. Simplify, then determine the value of the polynomial when n equals 2 and n equals negative 1. Okay, so we have to first simplify and then figure out what the value of that expression would be given particular values for the variables. Okay, so let's just start by simplifying first. Okay, you need to open up the brackets. This is positive, not a big deal. That's just going to open right up. Okay. Positive 1 multiplies times the negative 2, it just stays the same. Positive 1 times negative 3 stays the same. No confusion, magic, or mystery there. Okay, let's identify our types of terms here. We have n powered terms, or n single powered terms here. So -3 and -2 gives us -5n, and we have +4 minus 3, so that leaves us with +1. Okay. So that's simplified now. Okay, this is simplified. And if the question asked us to simplify the expression, we'd be done. And that is the first part of the question. It says to simplify. Right? If you look at the instructions on number 3. However, the next part says, then determine the value of the polynomial. Okay, so polynomial is a fancy term for this. Okay, this is technically a binomial because there's two terms here, but polynomial is just generic for any number of terms. And when n equals 2, okay, so we need to substitute n equals 2 in here. So solve for when n equals 2. I'm going to solve for n equals 2. Okay, so we're just going to substitute that in there. We'll go -5, and we'll put it inside brackets like that. So generally we do substitutions in math. For variables, we take the value of the variable, we put it into the expression in a bracket form like this, and then we solve it through. Okay. -5 times 2, a negative times a positive, this becomes -10. And then the +1 just comes down here, and so the final answer, -10 plus 1, leaves us with -9. Okay, so that's it. So solve that for -9. And the question also asked us to solve it for when n equals -1. So we'll take the expression again, and we will solve for n equals -1. And we'll do the same thing. We'll take the expression, and where the variable is, okay, the n, we're going to substitute -1. Okay, so here we've simplified it. Now here we've solved the expression. Okay, this expression here, we've solved it for when n equals 2, it equals 9. And I'm going to solve the expression again for when n equals -1. Negative times a negative. Again, this is a handy little memory aid here. It's a little grid. Okay, when we have two positives or two negatives multiplying, the answer is going to be positive. When we have mixed signs multiplying each other, the result is going to be negative. Okay, in this case I've got two negatives, so this becomes -5 times -1. When we have numbers beside each other in brackets, or brackets indicate multiplication in math, okay, -5 times 2 became -10. This is -5 times -1, so this just becomes +5 because it's a negative times a negative, which becomes a positive. That becomes +5 plus 1. Okay. And I'm falling off the bottom of my screen here. If I move this, -5 plus 1 just becomes 6. And that's the final answer for that polynomial when we substitute n equals 1. And in the second one, bracket -2n squared plus 6n plus 3. So again, the question's asking us to both simplify and then substitute values in to solve this polynomial expression. Okay, so again, with these simpler first expressions that they're giving to us, we don't have to worry about anything in front of this bracket, so this is going to open up and the terms will all just fall down here into the next line pretty easily. And in the second one, again, plus sign right here, so no need to worry too much there. We can be happy about this. This is all just going to open up and be the terms that they are once they come down into the next line. Okay, so we'll bring this down. We have 3n squared minus 7n plus 2, so that bracket just opens up, and this bracket's going to open up as is as well. because again, this is just a positive 1 here that's multiplying times every term inside the bracket. Okay, this is like a positive 1 multiplying times every term inside the bracket, because again, brackets, whenever you see brackets in math, you generally have to think of some type of a multiplication that happens. That's exactly what's going on here. This is a 1 understood multiplying times each of these terms before that bracket opens up. So it's not just that we're just popping these brackets off and jumping down here. It's that this is a 1 multiplying everything inside here, just like this is a 1 out in front here as well. Okay, these are both 1s. There's a 1 multiplying out in front here, and there's a 1 multiplying in front of every term there. Makes our life easy though, because when we multiply by 1, nothing changes. Okay, so there isn't just magic here that these brackets are disappearing. I need you to understand that, because as we move on, things will get more complicated when we start putting terms out in front here. So hopefully that's clear. Next step, let's identify our like terms. Okay, so we have squared term here, single power term here, constant, constant. So we're going to put all 3 of those terms together in the next line when we move down. So we have positive 3 minus 2 on the n squared terms. 3 minus 2, that's just going to be n squared. On the n terms, we got negative 7 plus 6. So that's just going to leave me with negative n. Negative 7 plus 6 becomes negative 1n. I don't need to write the 1 there, just like I didn't need to write the 1 there. 3 and 2, when I add those two together, I get plus 5. So there's my simplified expression done. That's the first part of the question. Okay, and just like in part A, the question is asking us to now solve this expression. Okay, so we need to solve this expression for the situation where n equals 2. Okay, so solve for n equals 2. So we'll take the expression and we will put 2 inside brackets, just like I mentioned before. So whenever you see the variable, the letter, substitute this value in by putting it inside brackets and just rewrite the whole expression. So n squared, this becomes 2 squared, negative n, that becomes 2 inside our set of brackets there, and then the plus 5 just carries down. Now it's a matter of solving for this and collecting all of those terms. Now 2 squared, again the squared term, the 2 exponent on top means we multiply 2 times itself, so this becomes 4. There's no sign in here, so this just becomes negative 2, and then the plus 5 down at the end over there. 4 minus 2 is 2, and then add 5, and we're left with 7 as a final answer there. Okay. Then, second part of the question is solve for n equals negative 1. Okay, same story. I plug in negative 1 inside a set of brackets wherever I saw an n in my original expression, the polynomial. Okay, let's start doing the math. Negative 1 squared, this is like negative 1 times negative 1. Negative times a negative is positive, so that becomes positive 1. This negative is like a negative 1 again. Negative 1 times negative 1. This next term becomes positive 1. Okay, because again, this is a negative out in front here, negative in front of a bracket. That looks like negative 1. So this is like negative 1 times negative 1 becomes positive 1. And then the 5, there's nothing else going on at the end over there, so the 5 just comes down. And then I have 1 plus 1 is 2 plus 5. Final answer there. Would you look at that? 7 as well. Interesting how one expression, even though I'm plugging in two very different values for n, end up giving me the exact same value out. Okay, so that's it for that section of lesson 6. Moving on now further into that lesson. Okay, we get into multiplying and dividing of the polynomials. So I certainly encourage you to go through this lesson here. It works through these examples for you. Breaks everything apart that you can see. In this first one, you've got 4x squared times negative 3x. So in the solution, you can see it pulls out the coefficient parts, the negative 3 and the 4. Okay, they're going to go together, and then the groupings of the x's will go together. So negative 3 times 4 gives you the negative 12, and then there's 3 x's multiplying, so that becomes x cubed. Okay, and you can just follow through all these worked through examples on what's going on here, and then we get down to the support question. Down to the support questions here. And we'll take a look at how to solve these support questions together. Okay, turn the page over. Okay, so this question here asks us to determine the product or the quotient. Okay, so product is a fancy word that refers to multiplication. Okay, so it's the answer. Product refers to the answer of multiplication, and quotient is a fancy word that refers to the answer from division. Okay, just back this up here a bit. Sum, we've seen that before. We see that term quite commonly. That just refers to the answer from addition. And if we're subtracting, oh, sorry, that shouldn't be written there. This should actually be difference, right? So if we're talking about negative and the answer is the difference. Okay, so those are the fancy terms here that refer to the answers of these four basic multiplication, or four basic mathematical operations here. Sum relates to addition, difference is the word we use when we're talking about subtraction, product is the word for multiplication for the answer, and quotient is the answer when we're talking about division. Okay, so looking at number 4, it's asking us to determine either the product or the quotient, okay, multiplication and division. Okay. Again, another side step back here. You know, addition and subtraction are just mathematical opposites of each other in terms of operations, just like multiplication and division are mathematical opposite operations, and so that's why these things often get grouped together. Okay, so for A, the question here is 3m squared times negative 7m. Okay, so now we're multiplying. We're not just adding or subtracting terms now. So a little bit different here, and like it showed you in the lesson, you will look at the coefficient part of these terms. Okay, so in this case, the number out in front, and then you will look at the letter portion of the term and deal with that. So just like it did in the lesson, we can combine the coefficient parts of this. So it's 3 times negative 7, because this is multiplying. We see two brackets right immediately beside each other in math. We always know that that is referring to multiplication whenever there's two brackets beside each other. So the 3 multiplies the 7. Okay, the coefficients multiply, and then the letters, or the algebraic portion of the term, they multiply each other. So this is like two little questions kind of built in to one here, where we deal with the coefficients and we deal with the letters, or the algebraic part of the term. And so this becomes negative 21. Okay, 3 times negative 7 is negative 21. A positive times a negative becomes a negative. And here we have m squared times m. Okay, so we have 2 m's here. This is like 2 m's multiplying here, and then we multiply it by yet another m. And so what we have are 3 m's multiplying together. So this becomes m cubed. And that's really what the exponent means up on top here. The power just represents how many of the same letter there are multiplying each other. Okay, so it's a shorthand way of representing 3 multiplications of the same value there. So it's negative 21 m cubed. Next part, B. Now this is kind of written in an elementary fashion. I want to change this right away when I copy this into your textbook or into your notebook. So we're going to write this as 12n squared, and there's really no need to have brackets here because division, don't get scared, division is written like a fraction. Okay, whenever we see a line here like this and there's something above it, the presumption is that this is in a big bracket on the top of the division sign here, or of this fraction. This is like the numerator of the fraction. This is the denominator of the fraction, and we assume that this is in a bracket here. So there's, math is sometimes, I guess, difficult for some people because there are a lot of these little assumptions that are just made and understood in the symbolism that is math. This is getting very abstract here, but there's a lot that needs to be understood to be able to be successful and just be able to interpret this question. Okay, just like in English, you have to be able to interpret stories. You don't just read words. You have to be able to put words together into larger concepts and in sentences and then into paragraphs. Same idea in math here. There are concepts that need to be learned and put together and carried forward. And we have to use all these skills as we get into higher level math. Okay, just like what we did here is we concerned ourselves with the number portion, or the coefficient portion, and the letter portions separately of these terms. We're going to do the same thing here. So I'm just going to actually draw a line right down here like this and kind of treat it as two separate things. Okay, and this is I'm just going to write it here. Don't normally like to do this. We don't normally develop mathematical solutions horizontal like this. We generally develop them down, but just to keep this in the frame a little bit better and save a little bit of space. The number portion here, the coefficient portion, I'm going to worry about this now. So this is 12 divided by negative 6. So don't even worry about the negative sign for right now. 12 divided by 6, that's just 2. But because it's a positive, okay, this is a positive 12, even though there's no plus sign there, we assume that to be positive. Positive 12 divided by negative 6, if you think of that little square box, again, if it is two different signs, okay, this little handy box here, when we have two different signs, the function's going on here, the result is negative. So this is positive, this is going to be divided by a negative, so that becomes negative 2 as the final answer. 12 divided by 6, if we don't even worry about the signs first, divided by 6 is 2, but because it's a positive and a negative, the answer is negative 2. Okay. Now I need to concern myself with the letters here. So this is basically n squared divided by n. Okay, I have two n's. Let's take a little side step here. Okay, I essentially have two n's on top and one n on the bottom. There's my n squared. Okay, I have two n's multiplying. A little dot like that in the middle indicates multiplication math as well. Another little symbol. N squared, n times n over n. Whenever I have the same value on the top of a fraction as on the bottom of the fraction, okay, they divide each other out. They divide into each other evenly. These basically become ones. Okay, and maybe we can take another little side step off of this here just to see how this is working in a little bit more concrete a manner. Let's just look at the situation where, whatever, just using a couple numbers here, 3 over 3. Okay, n over n means these are the same two values. This n value is the same as that n value. So I just use two of the same numbers here. Just happen to pick 3. 3 divided by 3, when I divide 3 by 3, I get 1. Okay, the 3 divides into itself one time, divides into itself one time here. 1 over 1 equals 1. Okay, and so that's what's happening right here. Now, again, whenever I multiply or divide something by 1, I'm just left with what I started with. And so really the only thing that's left here now, when I have n squared divided by n, these two guys divide each other out. They become 1s, which I can pretty much just ignore. Okay, and so the only thing that's left here is just that single n, and so that's what's left out over here. When I've got two n's on top and one on the bottom, one on the top and one on the bottom divide each other out. Okay, n squared divided by n. There's only one n left, and there is my final answer. Okay, so let's move on to C now. These simplifications cause a lot of grief. I think if you attack it very systematically, try and stay organized, it really helps. So the numerator on this, at the top of the expression, is written like that, 7ab squared. I like that. I'm going to leave it the way it is. It's alphabetical. Even though this is a higher order power on the b term. Okay, but we have the coefficient first, then the a term, and then the b squared term here, or not term, sorry, part of this term. Then on the bottom, what I want to do is I want to line up the letters here. Okay, so I'm going to rewrite that as the -3. So just like I had the letters lined up over here, and the numbers, the coefficients, I want to do the same thing here. And you can see in the question that it's written as -3ba. Okay, again, I don't know if that's a typo or if the author did that on purpose just to really kind of make sure you know what you're doing here, throw a little bit of a curveball at you. But let's rewrite this in proper alphabetical form. So I'm going to go 3ab. Okay, and that doesn't change this whole term or the value of this. Whenever you multiply an a times a b, your answer is the same as if you multiplied b times a. 3 times 5 is the same as 5 times 3. The final answer doesn't matter. In multiplication, you can change the order of two values that you're multiplying, and it makes no difference. So we're going to use that to our advantage here, just to keep this question a little better organized, so we can attack it a little bit better. Okay, I'm going to do the same thing I did above. I just want to divide these things here just to emphasize the numbers and the particular letters that are the same, because that's really where the simplification is happening here. The simplification is happening in the parts that are the same. Okay, because that's all we can do here. I can't simplify a b into a 7. Okay, but I can simplify a's and a's, b's and b's. Numbers themselves can be simplified. Okay. Now here, unfortunately, the 7 and the 3, they don't divide into each other nicely in terms of whole numbers. I could write this out as a decimal if I want, but there's really no need to do that in math. Fractions are perfectly fine as final answers, and in this case here, I'm just going to leave it like that. Again, if you look up at the little square thing that we have, Positive and negative, again, this is a positive 7 because there's nothing in front of it, so the assumption is there that it is positive. Positive divided by a negative. Final answer is going to be negative here, and I'm going to write this alongside. Okay, just as negative 7 over 3, like that. Okay, so I'm writing this as its own little fraction. Now, again, same thing as what happened up over here in the situation where I've got one letter above the other letter that are the same. Okay, I've got a over a. These both divide into each other one time each. Okay, a divides into this a, so it's like a 1 over 1 situation here, and this is like a 1. So because I have, normally the answer from this division would be written next right beside the fraction right here, but it's really just a 1. I don't need to worry about writing that here, because negative 7 over 3 times 1 is still just negative 7 over 3, so I'm not doing anything to the answer here. These ones just effectively cancel out, and I don't have to worry about, they divide each other out, and I don't have to worry about writing them over here in this part of the answer. In this situation, I've got b squared over b. Okay, so if we just take a little side step down here, that's like a b times b over b situation. That's my b squared over my single b on the bottom. So again, one set of b's will divide each other out top and bottom here and become 1s. So this is really like 1b as the answer just to this part of the question. Okay, when I just kind of do this separately, and 1b is just the same as b itself. Okay, so that's all that's left from this part of this larger problem here is really just this little b, and so that's all that gets written over here is just that one single b. So this is negative 7/3 b. Okay, if you felt the need to divide that and turn that into a decimal, it's fine, you can do that. I wouldn't worry about it. Just remember though that when you divide by 3, you're going to get a repeating decimal, so you should indicate that and not just chop it off. Okay, because 0.3 is not the same as 0.333333. So if you're going to do that, when you divide it out, and make sure you put the proper notation on top of your decimal to indicate that. Okay, moving on to D now. We have negative 3x divided by 4xy. Sorry, not divided by, multiplied by. And this is negative 2y over there. Okay. So a little bit different approach when we do these from the adding and subtracting. Again, this is multiplying here, but there are some similarities in how we attack the problems. Like we did before, I'm going to look at the number parts here, or just the numeric coefficient parts of all of these problems here, and I'm going to write all of those together out in front, because this is all being multiplied together here, okay, which is what's happening right now, but we need to simplify it. So we group all the numerical coefficient values together. So this is like negative 3 times the 4 times the negative 2. Okay, so I'm putting all those numbers out in front in my next step. Okay. Then I have an x from here and an x from here. Okay, so I'm just going to write those out like this for now. And I should indicate that, I guess. Okay, those are my two x's right there. And then I've got a y and a y right there. And then so I can write that in the same manner like that. Okay, so this is everything that we've got here, just rearranged and regrouped together. Okay, you can think of all of these as individual little pieces. I've kind of ripped them apart like little Lego blocks if you want. I've ripped these little Lego blocks apart and I've just arranged them so that they're the same type of little Lego blocks all beside each other. So my numbers are all beside each other. My x's are now beside each other, that I have two of those, and my two y's are beside each other over here. Okay, so now I deal with this mathematically. Negative 3 times 4 is going to give me negative 12. And negative 12, okay, so this becomes negative 12, and then negative 12 times the negative 2 becomes positive 24. So I don't need to write the plus sign right there. okay, but it's there. And then x times x is x squared, and y times y is y squared. And there we go. That's the finished simplified answer to that question. On to E now. Negative 28 a cubed over negative 7 a. Okay. Let's break this up. Negative divided by negative. This final answer is going to be positive because we're dividing a negative by a negative. That's going to be positive. 7 times 4 is 28, so 28 divided by 7 is just 4. Now we have 3a's over 1a here. So again, this is the situation where we have a times a times a all over a. Okay, there's my 3a's multiplying, my a cubed over the one single a on the bottom. So that means one of the a's on top and the 1a on the bottom, they divide each other out to be 1. And top and bottom, and so what I'm left with is 2a's right here, and those 2a's become just a squared. So when I've got 3a's on top and 1a on the bottom, one of the sets of a's divide each other out, and we're left with 2a's still remaining on top. That's a pretty straightforward one. F, we can zip through F here pretty darn quick. This is a nice easy one as well. It's just 8z cubed times 7. There's no letter portion to this term inside this bracket over here. So all we need to worry about is multiplying the 7 times 8. So this is easy enough. We can just make this 56z cubed. Done. Okay, very straightforward. G is a division. Again, it's written with the sort of the elementary division symbol. I'm going to rewrite that right away and make sure that we line up the letters on top, or each part of the term on top, with the corresponding terms on the bottom. So we have a 2, A, and B. So I've kind of exaggerated how I've rewritten this with the division. Okay, so again, I got rid of the elementary little division symbol, and I've converted this into a large division style or fraction style question here, which is really what it is. You know, you really need to get used to writing division this way in more advanced math. We typically don't use the little division symbol. This way I can divide this up and attack this in the 3 parts that it is. Okay, there's the number portion right here, the integer portion of this, and I've got the A parts here, the A letter, the A variables, and I've got the B variables. Okay, so we'll just write this over here. Negative 4 divided by positive 2, again, negative divided by positive is going to be a negative 2 answer. Okay, negative divided by positive is a negative answer. 4 divided by 2 is just 2. A cubed over A, okay, just like in the question above. Okay, A cubed over A leaves us with just A squared. Okay, A cubed divided by A, 3a's on top, 1a on the bottom. 1 divides out top and bottom, just leaves us with 2a's, and same story right here. A cubed over A is A squared. And then situation here, we've got b over b. These both divide out, top and bottom. That just becomes 1. So there's really no b's left to concern ourselves with in the final answer here. It would be like times 1. And we don't need to worry about that. This is done. Next one, H. Again, really straightforward here. Not as simple as F, I suppose, but pretty straightforward. We worry about the number parts, the 5 and the 4, and then we worry about the letter parts, the X's. Okay, so 5 times 4 is just 20. So we put those two together, gives us 20, and X times X is X squared, and that one is done. Get really pretty straightforward question there. Nice easy one. Right before they kick you pretty hard with the last question here, I. This is a very large type of a question when you first look at it. But again, with most of these, if you just break them down into little pieces, don't be scared of the mic audio. There we go. Now I think we're back on the audio. Last thing I'm going to do here for now, I again look at the numbers separately from the letters in these two different brackets here, and let's recollect them out in front here. Okay, I'm going to put the -3 over 5 and the -10 over 9 out in front. I've got an a and an a cubed, so I can, or a squared, that's going to finally be a cubed, and then just a b squared there as well. Okay, so again, think of these all like little Lego blocks if you want, or little building blocks, and there's the number blocks that get matched together here. The little a blocks get matched together here, and there's only one b type of block, the b squared block, and it just comes down over here. Okay. Now, I realize most of you have fraction anxiety and don't like dealing with fractions. So let's just deal with this like a couple of simple numbers here and approach it in the same way that we would a simple multiplication of fractions. I'm not going to do any pre-simplification at this point, even though we could. Negative times a negative, bottom line, this becomes a positive. 3 times 10 is 30. 5 times 9 is 45. Not the best way to handle that fraction, but it's the quickest and easiest way to handle it right now. Okay, so we'll leave it like that. We've got a times a squared. That leaves me with a cubed.